Today, I'll be showing off the recorder's capability for a scientific data analysis use case. To that end, alongside the recorder, I'll also be using UPython 3 from the Asset Store. This is a tool that allows for easy integration of Python into the Unity editor. This demo was built on top of the VR bowling demo, so check out that video on the details of the VR bowling demo if you have not already. First, a little refresher on how the recorder stores data. Recording files are plain text documents. They are formatted such that each new line in the document is a new frame of recorded data. If you record 500 frames of gameplay, then you end up with a document that has 500 new lines. From here, each object with the recordable component recorded on that frame is placed on the line and separated with two bar characters. From here, first is the object's GUID, then the Unity events performed on that frame, then its hierarchy data. This is blank if the object does not have a parent. The prefab name if the object has been associated with a prefab. Finally, the data of various components and variables that have been set up to be recorded using the recordable component, very typically things like the transform data. In this case, nearly all of the recorded game objects have their transform data listed first. Knowing this, we can easily create a Python script to parse through the data, and thanks to the many well-done plotting libraries available, we can create a graph of the data. For this example, we will write a script capable of plotting the position of a game object over time in frames. First, let's go over how the project is set up in Unity and its features. The UPython prefab has been added to a new version of the bowling scene. The bowling scene has also been edited to include a large 3D gizmo as a reminder of the world space 3D axis. In this case, keeping with the Unity conventions, forward is considered positive on the Z-axis. As you can see here, the recording playback UI has new windows for creating plots with Python. Before being able to use any of the Python functions in-game, we are going to start up the Python server that comes with the UPython tool. There are a few boxes that need to be supplied with the GUID of the object to be plotted, the file name of the recording file to be read, and the file name you would like to give the resulting plot. Keep in mind that if you run the script again and do not change the file name of the plot file, the previous one will be overwritten. Then click the Save button. You should see a Python command fill into the save box. Then click the Run button to run the saved command. The plot is shown inside this preview window as well as saved to the figs folder inside of the UPython directory. While we are here in the UPython folder, I would also like to point out that the recordings folder has been changed to be specifically inside the UPython folder, so that way the Python script can access our saved recordings. Let's go over the script that is the interface between Unity and Python. It is attached to this recording plot game object. This script is the one that we use to build and run the Python script. This script is also in charge of displaying the resulting plot image to the canvas. By the way, the plot rendering in-game is very easy. The plot is rendered using a simple raw image component. When the UPython game object sends back its data, we can convert it to a 2D texture and then set this texture to be rendered by the raw image. You can even place one onto the VR UI if your workflow would benefit from it. And this is the Python script. Here we are importing the RE module, which is going to allow us to parse through the data file named in the system argument. The Unity object class allows us to store the pertinent data from the data file for each object, most importantly the GUID and the transform data at the end. Next, we have some functions related to looping through the file and not saving duplicate GUIDs, and for looking up a GUID. Next, we open the data file and start a loop through it, using the built-in separation characters like double long bars, commas, and quotation marks. There is an additional check for recordables that do not store the transform data, as there are a few recordable components present in our scene that do not record anything, but exist to enable and disable objects and components during a replay and re-enable them for a recording, so these are skipped. All of the objects and their data for each frame is then stored. The object we want to check for is provided by the system arguments, and we use the GUID to build a plot, which is then saved to the provided name. The last bit here are settings for the matplotlib library to actually render out the plot. A message is then sent back to UPython to show where the plot has been saved.